I have another rice table equilibrium problem for us to solve. This one happens to be the water-gas shift reaction. It's one of the ways we can make hydrogen. Using carbon monoxide and water, then we shift the oxygen over to carbon to make carbon dioxide and then hydrogen gas. And at this particular temperature, the K for the concentrations is 5.1. Now, initially we have a flask or a reaction container that has 0.05 molar of each of these species, so of all of them. And we're going to determine what the concentrations of each of these species is at equilibrium. So we'll fill in the change portion of our table, which this is minus x because it's on the reactant side. We're going to use that up. This is also minus x. And since it's all 1 to 1, it makes it a little bit easier. Plus x and plus x. And so then when we come down to our equilibrium amount, that's going to be 0.05 minus x. Same here. And then over here, it's going to be 0.05 plus x. Next, we will need to substitute all of these equilibrium values into the equilibrium expression. Let's write the equilibrium expression right down here. And that should be K and products over reactants. So we have products, which is carbon dioxide, over reactants. Now we'll plug in all of our values, including the value for K. CO2 is 0.05 plus X. Okay, now that we have that all filled in, let's actually combine these two terms so that it's going to be a little bit easier to solve in the end. So I'm going to write this top as 0.05 plus x squared, and I'm going to write the bottom portion of this as 0.05 minus x squared. So and you'll see why in a minute. So now that we have that, we can take the square root of this and the square root of our K and simplify our equation down a little bit. So square root of 5.1, I'll just write that here so we remember what we're doing, equals 2.25832. And then that will equal this, but without the squares because we took the square root. Now, the reason we can do that is because there's a square on top and bottom. So having all of these equal to each other has its advantages in solving this problem. Now we're going to take this bottom portion, multiply it over here. So we should get, let's see here, 2.25832 times 0.05 is 0.112916. And if it appears that this number is different than if I took 2.25832 and times it by 0.05. It's because I left all the digits in my calculator when I actually wrote this out ahead of time. So that might explain some discrepancies if you have any. So negative x times 2.25832 is this. And that all equals my 0.05 plus x. Now, I'm going to move the 0.05 over to this side of the equation, and I'm going to move the negative 2.25832x over to the right side of the equation. And we should get 0.062916 equals 3.25832x. And then I will just divide both sides by 3.258 to get what x equals. So x equals 0.0193. So now that I know what x is, I can plug that back into each of these equilibrium expressions and determine what they actually equal. So if I do that, I should get, for both of these, since they're the same value, I should get 0.0693. And for the carbon monoxide and water, I should get 0.307. And these are all molarities. So molar, molar.